Hi, my name is Julius. Today we're looking at ladder problems. But before we move on, please like this video and subscribe to my channel. Before looking at this example, let's look at some situations here. In case number 1, we have a ladder being inclined at an angle theta, which is big, and there is possibility of this ladder toppling down once somebody start touching it at the bottom here. At case number 2, the ladder has been inclined at an angle theta, which is very small, and also at this situation the ladder is not very steady. When somebody climbs up beyond the middle of the ladder, there is possibility of it also slipping down in this direction. And case number 3 is where the angle theta is between case number 1 and case number 2. So for that, constructors and painters need to be very careful in choosing the angle while placing their ladders in their construction site. So let's switch to our question, and the question says a uniform ladder of mass 30 kg and length 5 meters, meaning our length here is 5 meters, rests against a smooth vertical wall. The vertical wall here is smooth, meaning there is no frictional force acting on it, with its lower end on a rough ground, and the rough ground here is this one here. It means there's that frictional force acting inward, because the ladder would slip in that direction, moving in that direction, and always friction opposes motion, and we shall have some force here acting in this direction, and that is the frictional force. So our frictional force F is going to be equals to, since the frictional force has been given, the coefficient of friction has been given here, let's call this normal reaction R from the ground, and then the normal reaction from the wall as S. So we shall have the coefficient of friction 2/5 R from frictional force is normally directly proportional to the normal reaction, and this is our coefficient of friction mu. So the ladder is inclined at 60 degrees. The angle between the ground and the ladder is 60 degrees. So when you trace this geometry, this is Z angles, which is also here 60 degrees to the horizontal. How far a man of mass 80 kg can ascend the ladder without slipping? So there's a man here who is ascending up this ladder starting from this direction there, but there's a possibility of him reaching to another area or another point where this ladder will skid off. So how far? Here we don't know, and we have to locate this distance, how far this man will go before this ladder will skid off. So if we take that point here and represent the man's distance with a known letter, say x, we shall have x there as the distance moved by this man from the bottom, and this ladder is said to be uniform. For uniform ladder, the center of gravity lies at the center of the match, so we can just estimate here without measuring. This would be our center of this ladder, and from the question here is 30 kilograms, so we have 30 g, and this man's weight is 80 kilograms, so it's also acting vertically down. We shall have it here. G. That is great. So the next is, before we move on, let's see that this angle would be equal to, when we drop some dotted line here, we shall have here also 60 degrees, 60 degrees And also 30G, which is the mass of this ladder here, is at the point of the middle where we divide this 5 into 2. So as I'll have here, this is 2.5 meters as the distance of the center of that ladder from its bottom. So here we're good to go. The next thing here is having some important ideas. The first thing is we need to remember that the sum of the forces along the x direction must give us 0. Also, sum of the forces along the y direction must be equal to 0. And we shall look at the summation of the torques or the moment also giving us 0. From here also our F has been mu r, which is coefficient of friction times the normal reaction from down here. So let's start resolving. I'm starting with vertical. Resolving vertically in that direction positive. The vertical component of these forces are these 3. So our R is positive. Then this one here will be 30 G minus 80 G must give us what? 0. And when we sum this, we shall have our R minus 110 G equals to what? 0. Adding on both sides, we shall have 110 G. So when we reduce this one down, we will end up with 1078 newtons as the normal reaction up of this ground to the ladder. And we take this one has been taken, we take this one here resolving horizontally. In that direction positive, and the horizontal component of these forces are only 2. We have S as the normal reaction from the wall and F as the frictional force from the ground. This must give us also 0. So that implies that F is equals to S. But from here, the frictional force has been given is coefficient of friction 2/5. So it means X is going to be S is going to be 2/5 of R, and our R has been 1078 newtons. Let us reduce this one down and have 431.2 newtons as the force exerted by the wall to this point of ladder. Oh, beautiful. So the next thing we're going to look is looking at the torque or taking moment. So taking moments about, now we have to name these points in which our ladder is touching the ground as A and where it's leaning against the wall as B. So let's take a moment about this one because we have 2 forces here which we can reduce it down. So we shall take a moment about point A. All anti-clockwise will be positive, and we can give some guide here that X direction, Y direction, any anti-clockwise is positive and any clockwise moment is going to be negative. So if that is that, looking at these forces, when you analyze critically, we have only 3 forces: the weight of the ladder, and then the weight of this man, and then the reaction of this wall to this. So when you look at this, only S will be clockwise, and that is going to be positive, and the 30 G and 80G will be negative, that is clockwise according to our guide here. So let's start from down here, from up. The sum of all torques equals to 0. So from S, we have to resolve it along that dotted line so that it is at 90 degrees. Moment is the product of the force and the perpendicular distance. So this force must be along that so that it's perpendicular to the distance, which is 5 meters. So when we do that, we shall have the length which is 5. This length is going to be multiplied by S, and that S is going to be sine of 60 degrees here, and then that is a positive. When you come down here, we're going to have a negative because it is clockwise, so I shall have minus. The length for this one is 2.5, and it's going to multiply 30G, and that is cos of 60 degrees, then minus the length of this man is what we're looking for, that is X, and it's going to multiply 80G, and that is also cos 60 degrees, must give us 0. So we know that from our previous work, our S has been 431.2 newtons, so we can start substituting in to find out something simple. So I shall have 5 is going to multiply 431.2 newtons, and sine 60 is √3 over 2, minus, when you multiply this, we have 75G, and cos of 60 is a half, so minus cos of 60 a half, making this one here 40G X, this will give us to 0. So when you multiply 431.2 by 5 and we divide it by 2, we obtain 1078 √3. When you divide 75 by 2, we get 37.5G, and minus 40GX will give us 0. We take this to the other side, so we have here 1078 √3 minus 37.5G must be equals to 40GX. So we divide both sides by 40G to obtain X. Then we shall have our X here equals 1078 √3 minus 37.5G all over 40G. So here, let's also work out 1078 √3 minus 37.5, because that is multiplied by 737, that is multiplied by 9.8. we have that divided by 40 times 9.8, we obtain 3.83 to decimal places meters. So all in all, this man has to ascend. That man of 80 kilogram can ascend 3.83 meters up the ladder before the ladder slip off. Now when you look at this problem here, we've just got our distance x, where this man will reach until this ladder will start sliding down, meaning after moving this distance x, which we have just got to be 3.83 meters, any step further taken, this ladder will just collapse and it falls down. Thank you very much for watching this video. See me in the next video, where we shall be discussing about the minimum angle required before this ladder will slide off. Bye.